All right, so transformations on sine and cosine. At the top of your paper, let's write the most basic equations that we could come up with. So y equals sine x and y equals cosine x are the parent functions for everything we're looking at today. So these are the wavy functions. And there's actually a funny term for this. These are called sinusoidal functions, which basically just means they're sine and cosine and they make waves, which we've been looking at. We're just going to summarize everything that we've looked at so far and write down how we can move these around. So I'm going to make this paper into 2 columns, and we're going to write on the left side what we're wanting to do, and on the right side we're going to give an example. So let's say that I want to translate up or down. We'll do one sine one and one cosine one. So if I want to take, let's say, sine x, so I'll start off with y equals sine x. What would I do to the equation if I wanted to move it up, say, 5 units? What would I have to add on to this equation?
Plus 5.
Plus 5. So that would move it up 5. Then let's say I take my cosine function, and let's say I want to move it down 7 units. What would I do?
Minus 7.
Minus 7. So that would move the whole thing down 7. And those are called translations, or you get to say translate. And we haven't done a whole lot of this. If you're just doing a simple translation left or right, which we'll get into more tomorrow, there's phase shift, which is a little bit fancier. We're just going to do something simple. If I want to move y equals sine x and I want to move it right, this is going to seem backwards, but I do sine, I do parentheses, and I do x minus however far I want to move it right. So let's say I want to move it right pi over 4, because we're usually graphing these in radians, and that actually moves it right pi over 4. It seems backwards because it's minus, but it has to do with some factoring stuff we did a long time ago. If I want to turn this into a 0, which is where it's going to hit the axis, then you subtract. Anyway, but this is how it works. Minus is right. And so then if I want to take cosine and I want to move it left, I will actually add. Let's say I'm going to go pi over 3 would move it left pi over 3. So I'm going to put a little note on this that these, they seem backwards, but this is how it works, and we were supposed to see this with the lab. Some of us figured it out and some of us were a little confused. But minus moves it right and plus moves it left, and this is inside the parentheses. So what we're doing is we're adding and subtracting to x before it goes into the function instead of on the end. Okay, so we can change the amplitude by performing vertical stretches. So if I want to do a vertical stretch, which basically increases your amplitude, we make the number in front of sine and cosine a little bit larger. So if I do something like 2 sine of x, that'll make your amplitude 2, where on the parent function it was only 1. And even if I use, it could be any number that's bigger than 1. I could use 4.5 if I wanted to. We don't usually, but you could. That would do the amplitude of 4.5. And in general, your number has to be bigger than 1. So next to vertical stretch, I'm going to put a greater than 1. A is the number over here, our coefficient, if you will, in front of the sine and cosine. So if we want to decrease the amplitude, this is sometimes called a vertical compression. It's like you're taking your hands this way and squeezing it to make it shorter. I'll pretend that's what happened to me. Then you're going to use an A that is less than 1. So this would be like fractions, decimals, things that are like proper fractions, things that are less than 1. And this would decrease your amplitude. So things like y equals 1/2 sine x, and y equals, we'll say, 0.75 cosine x. So here, what this does is it makes the amplitude 1/2 instead of 1, and this one makes the amplitude 0.75, and it can just be any number that is less than 1. And then the last thing that we have learned, not the last thing, but one of the things that we learned is how to do reflections. So if we're going to reflect over the x-axis, so basically this is when you're flipping it, you put a negative in front. So I could have y equals negative sine of x, and it can be with an amplitude number. I could do like -5 cosine x. If this number is negative, that flips it over. So this flips it. This part changes the amplitude, and they just kind of go together. So let's put some examples down at the bottom. Maybe I didn't want to divide my page all the way. That's okay. I used pencil. I can erase that. Do just some quick examples and we'll be done. So let's say I have an equation like y equals -2 sine of x plus 4 on the end, and it says to list all of the transformations. You can go from left to right, right to left, but have a system to make sure you're not missing anything. This negative sign right here creates a transformation. Yep, it reflects it over the x-axis. The 2 changes the amplitude to 2. Or you could say it's a vertical stretch. And then what does the plus 4 do? It moves it up 4. We'll just put up 4. You could say translates up 4. So that's all of the transformations from the parent function sine of x, the one that only goes to 1 and -1 and all of that. Okay, and then let's say I have, for the next one, y equals 1/2 cosine parentheses x minus pi over 6. So there's a couple of things going on here. The 1/2 changes your amplitude. It makes your amplitude 1/2. You could call it a vertical compression if you wanted to. What happens when I put the minus pi over 6 inside the parentheses? Okay, so it moves it right pi over 6. And that's the one we said was kind of backwards. Minus is right and plus is left. All right, I'm going to do one more. Hopefully you've got room down there somewhere. This one's going to have a lot of stuff. So I'm going to do y equals -3/4 sine parentheses x plus pi over 2 close parentheses minus 8. So we just want to make sure we're looking at each tiny little piece. So the negative up here is going to be reflection. It's going to reflect it over the x-axis. The 3/4 gives us the amplitude. What else do we have going on here?
Left.
Okay, it moves left pi over 2, and what else?
Down 8.
Down 8. So we're just going to be able to look at this and understand all of the different pieces and what it does to the graph.